Here's integrated 3, it's 10-185. Consider that ln2 equals this little decimal and ln3 equals this decimal number. Why is ln2 less than 1 and ln3 is greater than 1? For what value of x does ln x equal 1? Well, that's a nice question. So we know that the base, see how there's no base written here? We know that that base is actually e. But we also know that e can be approximated by the number 2.71. So ln to the 2.71, or ln base 2.71 of 2 equals what? Well, I mean, we know what it equals, but if you change this into exponential form, this is in logarithmic form, then I don't know if you remember that, but if I have log base b of x equals y, I can change that. I can say b to the y equals x. And they show it in your math notes box. Well, I can't remember exactly where that box is, but, and I've given you a piece of paper with all the properties of exponents. This is logarithmic form, and this is exponential form. Right there. So we want to turn, so if I wanted to turn this into exponential form, I would take the base and raise it to some power. Well, actually, you can check this on your calculator. You can go 2.71 and raise it to that power, and it's going to end up equaling about 2. And actually, if you take e, which is 2.71, and raise it to that power, it's going to equal about 2. So 2.71 raised to what equals 2? Well, even though we know it's 0.69, think about what you're doing when you raise something to a power. When I raise something, if this were raised to the first power, it would be 2.71, but that's too big. It has to be raised to a power less than 1 for it to equal to, for it to just equal 2. Just think about that. And then likewise for this one, this is ln base e of 3. If I put this in, this is in log form, but if I put it in exponential form, I'll have 2.71 raised to what power equals 3? Well, 2.71 raised to the first power would be 2.71, but that's too small because we want to get 3. So 2.71 raised to the something a little bit more than the first power would give me 3. And that actually, there was another question they asked. For what value of x does ln x equal 1? Well, it's e. Ln e equals 1. I know. Get out your calculator and mess around with this thing. You'll see. And then letter B, it says, use the properties of logarithms to write each value below as an expression involving ln2 and or ln3. Then use the given values for ln2 and ln3 to evaluate each of the expressions without a calculator. So they give you ln6. Well, there's a log law that looks like this, or a property of exponents looks like this. Because these natural logs, they obey all the same properties. They have all the same properties of exponents that these logarithms have. Okay, so this is base e, remember. And if I have something times something else, this argument is something times something, they're factors, then I can split it up into 2 different logarithms added together. So remember, the multiplying gives you the added logs, and the dividing gives you the subtracted logs. if you had that sheet of paper, the log law. I usually have one sitting around right here. No, I don't happen to have it handy, but anyway, this is the one that you need. So I broke it apart into 2 times 3. So ln of 2 is 0.69 because they told us that. And ln of 3 is 1.0, whatever that number was. And then when you add them together, you get this. And then natural log of 12. So you could have said it's 2 times it's ln 2 times ln 2 times ln 3, because 2 times 2 times 3 makes 12. But we just got done doing ln of 6. We just found out like 1 minute ago that ln 6 equals this value. So I want to split it into ln 6 times ln 2, because ln 6, we've already done all that work. And then ln 2, we know that that was 0.69315. So if I break it into ln 6 and ln 2, then I just add them up, I get this. And then ln 16, well, that one I'm going to use an exponent. There's exponents. Really what I could do is say that's ln 2 times ln 2 times ln 2. Let's see, 2 times 2 is 4 times 2 is 8 times 2 is 16. So I would have 4 ln 2s, right? So I would just multiply ln 2 by 4. And that actually works. And there's also a property of logarithms that says this comes around out front. Okay. Oh, and that's not supposed to be up in the air. It's supposed to be just ln 2. Okay, and then this is ln a third. So that's 3 to the negative 1. So I'm going to use that property of logarithms that says the negative 1 comes out front. And then times just ln of 3. Well, ln of 3, they told us was 1.0986, right? And then multiply those together and you get this.